Hey, I have a great idea for an app and you work in IT, so as a programmer you can program me this, right? Did you just call me a programmer? Yes? Alright now, it won't be that dramatic, but so that you can categorize all those software job roles correctly and once for all, but also know what to expect in which direction. I'll summarize the most relevant software professions for you and give you an overview where they are in the IT landscape. That way you won't run the risk of being subjected of an angry Fedora's reign because you said programmer to a software engineer. Hi, my name is Ayhan, I'm a freelance software engineer in Germany and I'm sharing my experiences to software engineering, career progression and the self-employment in the most entertaining way possible to you guys. Have fun! Mobile and web developers are implementing applications for the mobile devices and the web. They use programming languages like JavaScript, TypeScript, Swift and Kotlin, and frameworks like React Native and Flutter. Their goal? User-friendly apps that are aligned with user experience and business goals. They are combining technical coding skills with an understanding of design and user experience to design intuitive applications. Their tasks include testing app compatibility and performance on different devices and browsers, as well as updating applications for new features and security measures. These developers need to constantly educate themselves to keep them up to date with the newest tech. Front-end developers develop the user interface of websites and apps for an excellent user experience. They use HTML, CSS and JavaScript or TypeScript to craft beautiful and interactive pages that run well on all mobile devices and browsers. Working with designers and backend engineers, they ensure smooth integration of design and functionality. And they also optimize their pages for performance and ensure accessibility, like integrating screen reader capabilities for blind audiences. With ongoing training in technologies like React, Angular and Vue, they stay in the forefront of the web development to create new and user-friendly solutions. Backend developers work on server, database and application logic of websites and apps. They build the architecture that enables front-end systems to efficiently retrieve data and perform operations. They achieve this by developing APIs, libraries and server applications. Their craft may include Java, Kotlin, Node.js, Python, Ruby or many other languages. They create robust and scalable solutions for complex data processing. And they also ensure security, data integrity and store user data in SQL and NoSQL databases. By optimizing server performance and efficient data layer strategies, backend developers ensure the performance and reliability of digital systems. Full-stack developers are involved in both the front and back end of web applications. They develop applications from the idea to the implementation, design user interfaces, program server logic, and manage databases. They work with technologies such as HTML, CSS, JavaScript, TypeScript, Node.js, Ruby, Java, Kotlin, Python, and databases such as MySQL or MongoDB. Their versatility allows them to react flexibly to changing requirements and create comprehensive solutions that improve user experience and back-end functionality. Full-stack developers, although not as deep as the experts in their respective domains, are known for their broad knowledge of software development and contribute significantly to the efficiency and success of projects, especially in agile environments. And now the one everyone was waiting for, or not. Software engineer is basically a collective term of developers who specialize in front-end, back-end, web and mobile. They specialize in software development in a broader sense and use engineering principles for the entire development cycle, from analysis to maintenance. Their job is also to reinvent the wheel where necessary, but to draw on and identify existing solutions where possible. Accordingly, their languages and frameworks include all languages from JavaScript, Python, Java, .NET, C++ or other languages depending on the project requirements and the industry. And in addition to technical know-how, creative problem solving and communication skills with stakeholders like product owners or managers are essential for this role. They are constantly extending their industry knowledge for new technologies, efficient problem solving patterns, and are deployed across industries. DevOps engineers usually act as a link between backend and infrastructure. And here they ensure a collaboration and automation between backend developers and IT operations. They provide CI/CD pipelines and automate the deployment of applications and the infrastructure to ensure an agile and fast-moving development. For this, they are using specialized programming languages and frameworks such as Terraform, serverless framework, proprietary cloud provider SDKs, and scripting languages such as Python and Bash. All of this also known as infrastructure as code. Site reliability engineers are the interface between development and operations, and they build scalable and highly available systems. They ensure the reliability of IT systems by automating and eliminating routine tasks. And they are also responsible for the visibility through performance measurement metrics, but also for crisis management in the event that something goes wrong somewhere. This is also known under the term design for failure. Their toolset includes frameworks like Terraform, scripting languages, pipeline toolings like Jenkins, or proprietary solutions from cloud providers such as Amazon Web Services or Microsoft Azure. QA engineers focus on the quality assurance of software systems through tests and regressions. They create test plans and carry out both manual and automated tests to find bugs in applications before they can reach the users. They work closely with developers and project managers to ensure that the software meets the requirements and standards. They use various testing tools for functional, performance, usability, and security tests. Their detailed analysis and feedback are crucial for product quality, minimizing errors, and improving user experience overall. And all of this often makes QAs the domain experts of those software products. UX engineers, UX stands for user experience, combine technical skills with an understanding for design and user needs to translate user-centered design into functional web and app interfaces. One might say they stand between development and design, creating prototypes with interactive elements to improve usability and user experience. They work closely with designers to ensure that the products are technically flawless and user-friendly. They use design tools such as Figma or Sketch for precise implementation of design as code. Through user feedback and usability tests, UX engineers continuously optimize the products and form the link between what is technically possible and what are the user needs. Security engineers are the experts for IT security. They protect networks, systems, and data from cyber threats. Their tasks include designing and configuring security systems with firewalls and VPNs, as well as carrying out security audits and responding to security incidents at lightning speed. They developed security guidelines and train employees in security awareness and advise product teams on how they can make their products safer. New exploits and vulnerabilities are constantly being uncovered. So security engineers always need to keep up to date with the latest developments in these fields. They play a key role in protecting sensitive information, complying with data protection laws, and building trust in an organization's security. Embedded engineers develop software for embedded systems. Who would have thought? Usually in devices such as industrial machines like robotic arms, control units in vehicles, household appliances, or medical instruments. They design hardware-related software, which means they always have to take the memory, computing power, and energy consumption of their programs into account. Using programming languages such as C, C++, Rust, or whatever's fresh and new right now, they create highly efficient applications and ensure the seamless integration into the hardware. Their knowledge includes operation systems, microcontrollers, sensors, and communication technologies in order to develop robust systems that function in real time. Software architects are specialists in IT responsible for design and monitoring of complex systems. Their main task is to define the technical direction of projects aligned with business goals. They design the system structure, select technologies and frameworks, and define protocols for optimal scalability, performance, and security. Software architects are often the evolutionary stage of software developers who, with their experience, have seen many problems and solutions, and therefore have a good appreciation of how systems systems behave at a higher level and what disadvantages certain architectural decisions entail. They promote best practices, evaluate new technologies, and provide technical leadership to teams to ensure efficient implementation of the architecture. Solution architects design IT solutions that support business objectives. They analyze requirements, develop solution concepts, and design the optimal technical architecture. They deal with the architecture of complete solutions, which often comprise several software solutions, systems, and services. This role requires a deep understanding of business processes in order to find the optimal and customized solutions for the business. The goal of solution architects is to develop a comprehensive solution strategy that is not only technically satisfactory for the development teams, but also encompasses the business goals and visions of the organization. Enterprise architects design, plan, and implement the enterprise architecture in order to effectively implement business and IT strategies. They do this in collaboration with the stakeholders and analyze the strategic requirements of the company. They define the structural framework and develop a model to support the company's objectives. This includes, among other things, business processes, IT, data structures, and infrastructure, and combines them into an all-encompassing framework. Their work minimizes the risk through system integration and contributes to the long-term success of the organization. And that's all. If you liked this video, give the like button a slap as if it had called you a programmer. And I am aware that this list is super opinionated. So if you're furious that I didn't cover your favorite role, leave me an angry comment. But if you didn't think that it was that bad and just want to know more about certain aspects of software development, feel free to leave a comment and subscribe so you don't miss anything in the future. Bye.